Hello everyone. So here in this video we are going to see the design of the base slab. Actually we are not going to see the complete design because it involves the higher study of the plate theory. So we are just going to see what are the total loads which is going to come on the surface of the base slab. Actually the loads will come into the two sets. The first set of load is going to come on the edge of the base slab. If this is the external diameter of the base slab and this one is the internal diameter of the base slab, so the one set of load is going to come on the external edge on which the tank wall is made, and then another set of load is going to come on the internal diameter, within the internal diameter of the base slab. This will be throughout the base slab. Okay, this load is throughout the within the internal diameter of the base slab. So let us calculate both these loads, set of loads, and then add it together and then see what is the total load which is going to come on the base slab. So we'll remove this diagram, and as we know that on the edge of the base slab actually the tank wall is made. So there will be three different sources of load. The first one would be load from dome, another one would be load from ring beam, and then load from the vertical tank wall. So what would be the load from dome? Actually the dome thickness is very less, and so the only load, it's the self weight of the dome is ignored. So only load which is going to come from the dome, top dome, is the vertical component of meridional force. Just like this, if T1 is the meridional force, then as we have discussed that horizontal component of T1 meridional force, T1 cos theta, is going to be applied on the top ring beam, and similarly this vertical component of meridional force, which is T1 sin theta, will transfer from the top dome to the top ring beam, and then from the top ring beam to the tank wall, and then from the tank wall to the edge of the base slab. So we just have to calculate this T1 sin theta, and you know that T1 sin theta is a uniformly distributed load. So we have to multiply it with the perimeter of the total perimeter length of the circumferential length of the circular tank. Okay. So load from the top dome will be T1 sin theta multiplied by 2 pi r. So sin theta we can calculate just like we have calculated cos theta, so you can get this value very easily, no problem. Okay, now load from top ring beam, what would it be? The self weight of top ring beam will be calculated. Self weight can be calculated by volume of concrete multiplied by density of concrete. Density of concrete is 25 kilonewton per meter cube. You should remember it, 25 kilonewton per meter cube. And then volume of concrete is equal to cross sectional area multiplied by length of the top ring, total length of the top ring beam. तो क्रॉस सेक्शनल एरिया क्या होगी, 250 mm थी और 300 mm थी, दोनों को मल्टीप्लाई कर लिया और पाई इंटू 2 पाई आर कर लिया, तो उसे मल्टीप्लाई करके हमें टोटल वॉल्यूम मिल जाएगी. टोटल वॉल्यूम को डेंसिटी से मल्टीप्लाई कर लिया और फिर ये वेट भी मिल जाएगी, सेल्फ वेट ऑफ द टॉप रिंग बीम. तो ये भी लोड आ रहा है ऊपर से, ये भी लोड आ रहा है. अब तीसरा लोड क्या आ रहा है एज ऑफ द बेस स्लैब पे, सेल्फ वेट ऑफ द टैंक वॉल. Self weight of the tank wall, self weight of the tank wall can be calculated again by multiplying the volume of the concrete with the density of concrete. So this is the density of concrete, 25 kilonewton per meter cube. And how can this be calculated? The volume of concrete will be the area of cross section multiplied by total circumferential length. So let me show you by a simple diagram. If this is the tank wall, this is the tank wall, and this is the top ring beam, and this is top dome. So you remember the total length of the tank wall is 4 meter. Okay, but out of this 4 meter, 300 mm is the depth of the top ring beam. So we have already calculated the self weight of the top ring beam, so we do not need to consider that self weight again. So we have reduced here 4 minus 0.3 meter, and thickness of the this tank wall is 175 mm. So we have just multiplied it 0.175. So you can easily calculate the volume of the tank wall by 175 0.175 meter thickness multiplied by length into multiplied by pi into diameter. Diameter is again added here 0.175 because this is the tank wall. So total length will be external diameter multiplied by again 25 kilonewton per meter cube, and you can get this weight, or add all these three loads to get this final value of the total load on the edges. So you can get it very easily 1214 kilonewton. Similarly, there will be load due to water inside, and it will be distributed throughout the tank base slab within the internal diameter. So how can you calculate it? Similarly, the same way we have to use the volume of water multiplied by density of water. Density of water is gamma W, and gamma W is equal to 10 kilonewton per meter cube. You should must remember it. And 10 kilonewton per meter cube multiplied by pi r square h. Pi r square h is the volume of cylindrical cylinder. So pi r square h, and this you can get it. Okay. Similarly, you can calculate self weight of base slab. Base slab self weight, we don't know the thickness of slab. So thickness is assumed to be diameter by 35. So we get almost the data near to 350 mm. So take 350 mm here thickness and multiply it with the density of concrete. You get this value 8.75 kilonewton per meter square. Now just you have to know the total area of the base slab inside the internal diameter. So you just multiply it, not internal diameter but external diameter. So you add 12 meter plus 2 into 0.2 meter to get the total external diameter, which is equal to 12.4 meter, and multiply this value 8.75, which is the self weight above you have got, multiply this value with the total area of the base slab, and we can easily get it this value. This is the total self weight due to the base slab. Now sometimes finishing load is also calculated. Sometimes we apply some extra finishing on the surface inside the internal diameter. So if we assume that the distributed finishing load is 0.6 in kilonewton per meter square, then we just have to multiply it with the internal diameter, area of the internal circle, pi by 4 into d square. So d यहाँ पे लेना है 12 मीटर, and then you can easily get it finishing load. You may ignore it or you may consider it. There is the answer is not going to be wrong, but finishing is important. So we add all the above three loads: finishing load, self weight of the base slab, and the total load due to the water contained inside, and we get this load, this value of load, which is distributed throughout the base slab within the internal diameter. And as soon as when we add the total load, the load within the load on the edges of the base slab, which is 1214, sorry, you just take it. Okay, so when we just so when we add the loads 1214, which is on the edge of the base slab, with this value 15648, which is distributed inside the base slab, when we add both the loads, we get almost data is equal to 6863 kilonewton. This is the total load, 6863 kilonewton. Okay, so this is the total load 6863. Here it is calculated, and this is being exerted downward from the base slab, and base slab is supported by another ring beam. So ring beam will apply the same amount of load in the opposite and equal amount of force in the opposite direction as per the Newton's first law. So Newton's third law. So this total load you can easily calculate it, and according to this load we design the base slab. So design of base slab actually involves the plate theory, which we have not studied, and it's beyond the scope of this course. So we are just confining ourselves to here. We will meet in the next class. with the designing of staging. Okay, thank you.